Our last statement connective is the biconditional, which is also known as material equivalence and expressed in English as if and only if. It's actually the conjunction of two conditional statements that mirror each other, specifically if A then B and if B then A, which we can express symbolically as open parenthesis A, horseshoe B, close parenthesis, ampersand, open parenthesis, B, horseshoe A, close parenthesis. Note that in the second conjunct, the antecedent and consequent are reversed. However, in sentential logic, we notate this relationship by using the triple bar thus. Here's an example. Donald Trump is President of the United States if and only if he received 270 or more votes from the Electoral College. That is, receiving 270 or more electoral votes is both necessary and sufficient to win the presidency, and Trump did just that. Here's a video from Professor Delaplante that explains the biconditional.
You may have heard the expression if and only if in a math class or some other context. As the name suggests, A if and only if B is formed by conjoining two conditionals using the if rule and the only if rule. So it asserts two things, that A is true if B is true, and that A is true only if B is true. You can use the if rule and the only if rule to translate these rules into standard conditionals. When you do, the expression looks like this. If B then A, and if A then B. This asserts that the conditional relationship runs both ways. Given A, you're allowed to infer B, and given B, you're allowed to infer A. It's not surprising then, and this is also called a biconditional. You might encounter the biconditional written in different ways, but they all mean the same thing, that A implies B and B implies A. Biconditionals show up a lot in formal logic and mathematics. They're used to demonstrate the logical equivalence of two different expressions. From a propositional logic standpoint, the defining feature of a biconditional is that the claims A and B always have the same truth value. If A is true, then B is true, and vice versa. Here's an example of a biconditional relationship whose truth is obvious. Let A be the claim that the triangle ABC has two equal sides. Let B be the claim that the triangle ABC has two equal angles. And it's clear that if A is true, then B is also true. The sides AB and AC are equal. From the diagram, you can see this requires that the angles at B and C must also be equal. And it's also clear that the converse is true as well. That if a triangle has two equal angles, then it also has two equal sides. So if B then A is also true. But if both of these conditionals are true, then we can say that A is true if and only if B is true, and vice versa. One of the helpful things about learning about the biconditional as a concept is that it helps us to remember that ordinary conditionals are only half a biconditional. They only go one way. If A implies B, it doesn't follow that you can go backwards and say that B implies A. It reminds us that you need to argue or demonstrate that you can run the inference in the other direction as well.
And here's another philosopher, Eric Gerlach, to give us the truth table for biconditional sentences.
A biconditional, if and only if, is a conditional that works both ways. It is the combination of both if A then B and if B then A. We symbolize it with the symbol we use for conditionals along with its opposite together. Some symbolize it with an arrow with points on both ends, others with an equal sign with 3 instead of 2 bars. Let us say that A stands for the statement, you give me an apple, and B stands for the statement, I give you a banana. This means that A if and only if B stands for, you give me an apple if and only if I give you a banana, a promise that works both ways. For the promise to hold true, if you give me an apple, I must give you a banana, and if I give you a banana, then you must give me an apple. In the first of our 4 cases of possible truth values, if you give me an apple and I give you a banana, the two-way promise holds true. In the second and third cases, when one of us gives the other something but does not receive what they were promised in return, the two-way promise is false as our arrangement is broken. In the fourth and final case, our arrangement is unbroken if neither gives the other anything, and the statement is true because it has not been shown to be false, just like in the third and fourth case for a conditional. Just as for if-then, if and only if is true when both sides are false, which leads many to make mistakes. When A and B have the same truth value, both true in the first case and both false in the fourth case, the biconditional is true. When A and B have different truth values, when one is true and the other is false in the second and third cases, the biconditional is false.
So biconditional sentences are true whenever its members have the same truth value. That is, they are either both true or both false. Otherwise, a biconditional is false.